Okay, see Lindelof videos, volume of a solid with base of f of x minus g of x, which is really weird. And we're going to use perpendicular cross sections to the x-axis. So let me show you the question really quick. This is from the exam. So here's the exam here, and this is the question that we're going to be answering right here. So the question that we're aiming at right now is this question right here. And what they're suggesting to us here is this, and this is really, really important. It says the region R is the base of a solid. So it's the base of a solid for each y where y is greater than 0, less than 2. The cross-section of the solid is taken perpendicular to the y-axis. So perpendicular to the y-axis means this. This is what we're supposed to get from that. They say perpendicular to the y-axis. We're saying we're going to be making these rectangular bases. We're going to be making these rectangles. So here's the top of our rectangle, if you don't mind. And here are the sides to our rectangle. But when we place these things down, this is a side view of that, but when we place these things down, what we're going to see only is this. We're only going to see this top right here. So if we were looking down on it, it would look like this. A rectangle here, and another one, and another one, and another one, another one. And they're just infinitely close together. So we have this rectangle here, and we have to keep that in consideration. So I guess what I would like to tell you is this. Now when we're looking at this, we used to look at this. This is the bottom, and this would be the top. Now we're looking at it sideways. So if we were this little guy right here, if we were this little guy right here, then we wouldn't be standing here. We'd be standing, in the weirdest way, we'd be standing here. And this would be the bottom, and this would be the top. So it gives us a lot to think about. So let's see if we can't do that. So here we go. First thing it says in terms of y. So they gave us that y is equal to the square root of x. If that's true, then if we have to have this thing in terms of y, then we solve for x. X is equal to y squared, isn't it? Something to really, really think about. And to keep that in context, that's the blue function here, isn't it? The orange function was that y was equal to 6 minus x. Well, if that's true, then x would be equal to 6 minus y. So hopefully you can see that. So this actually corresponds to this curve here. This is really, really important because we have to get an idea of what's going on here. So the width of this thing, remember we're doing these cross sections that go this way, right? We're doing these cross sections that go this way. So the width is this orange curve here minus the blue curve. So that would look like this. So if I set up the width of that thing, this is really weird stuff. The width would be this curve. Remember, we got our little guy here. Our little guy is here. This is the bottom. He's looking up. So this curve is on the top. So that's the 6 minus y curve, isn't it? And the bottom, we have to subtract out the bottom, minus the bottom curve, which is the blue curve, which is the y squared curve, which is y squared curve. So hopefully you can see this is the width, right? So this gets really weird because now what we have to do is we have to come up with the base. So we're going to come up now with this volume. And the volume of this thing is the addition of all of those rectangles that we're putting in. Right? Remember that this is this piece that looks like this standing up. And this piece right here is the top, and that top is right here. But this thing is stacked down like cards stacked on their edges, right? So it goes from, check me out here, this is really important, from 0 to 2, right? From y is 0 to y is 2, right? It's going this way. So our interval is based on the y value, so it's going to be 0 to 2. Of what? Well, what's the area of a rectangle? The area of a rectangle is base times height, so it's 2y, because they gave us that the height is 2 times the width, and the width was 6 minus y squared. Really, really, really important here. That first off, if they ask this thing in terms of y, that everything must be in terms of y, including the variable of integration here, so dy. It says, on the instructions, it says that we don't have to come up with the volume itself. We don't have to evaluate the volume. We just have to come up with its expression. So this is what your work needs to look like. We changed our equations from y in terms of y to in terms of x in terms of y, and then we found our width. And we remember we found our width by looking, in the case of y, where the little guy standing here, it's top minus bottom. And then they told us in our instructions, that the height is 2 times y. So here we have it. I hope this is really helpful. These things are actually pretty easy on the exam, but you have to prepare yourself to see them. It's not something you're really going to have time to figure out on the run. So I hope this is helpful. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. Thanks.